Okay, hello everybody. Yeah, next topic. The last one was inequality measurements, and later on we will hear from some fellow student something about some little exercises about inequality, how to measure inequality, and now we want to go a little bit deeper what we have heard already in macroeconomics about inflation and price developments, a very actual topic, price developments and how to measure price developments. You know this from macroeconomics, where we have talked about inflation in general, which is a weighted arithmetic mean. But this is, of course, not the only way in how we can aggregate prices. And for this, we will go in more detail how it is possible, because there is, of course, no right way to measure prices in general, but there are reasonable ways, and then you have reasons to do it in this way or in another way. And about this, we will in general ask the question how not a single price. This we can see if you just go to the supermarket, what is the price of a single good, but how can we aggregate single prices and then come to something like a price index, and how shall we do this? And about this we want to talk today. Yeah, for this we just start with the three goods economy, and let's just ask, what is or how would you calculate the average price of the year 2015 and 2016? And then we can ask if these are three consumption goods. We have also the quantities which we are consuming, and then we can ask, we see what kind of idea you have to calculate prices. What would be a reasonable way if we have a situation like this? So we have three goods. What would be your first idea to average prices in these 2 years? Just a reasonable way, or in your hat. Internet can, of course, participate. We have three prices. What would you do to average the price? Yeah, yeah, just the arithmetic mean. I think this is, as always, so to speak, just the first idea, and it is, of course, a reasonable way to do it. So hopefully, yes, it's not a picture, so you can just copy it and put it into your Excel file. And here I would recommend this one. There, maybe you know that you can choose between the different formats, how to copy from a PDF or a PowerPoint or some else format, and this you should also try. because just copy and paste, so Control C and Control V sometimes creates a format which you cannot really good use in Excel. So just try this. Okay, so then let's say average price. This would be then just 1/3 times our three prices. So 18 and 80 period 3. The next one, how would we calculate if we have also the quantities? What would be the total consumption of these three goods in these 2 years? What would we then calculate? So how much euros do we spend in the year 2015 and 2016? Yep. And then, yes. So price times quantity and then summing up. So this would be then 11 times 4 plus 10 times 10 plus 32 times 2 would be 210 and 223. Maybe we just add this. No. A bit too long. How can I change this? I think in this way. Nope, doesn't work. Uh, Now it works. So this would be 1/3 P1 plus P2 plus P3, and this would be P1 x1 plus P2 x2 plus P3 x3. Well, now we could discuss, of course, somehow it is reasonable, but does this really represent the change of a price level? Or what kind of arguments we could find that maybe this is not so the first and the second one does not represent the change of the price level. If you also remember what we have said about inflation, talking in macroeconomics about changes in price levels. Idea? Yep. Yep. No, it's not the geometric mean inflation rate. Geometric mean we use if we are take the mean of growth rates. What was the inflation, or what was the consumer price level? How did we calculate this? I quite often make the example, well, a washing machine we are buying every 5 years, and a milk we are buying every second or third day. And a washing machine costs medium size, maybe 500 euros, and a liter milk about €1, €1.15. And then taking the average of these two prices, then more or less the milk would vanish. But on the other hand, in order to calculate at a reasonable price level, in order to say, okay, that you also keep in mind the importance, qualitatively spoken, of the good, what we are doing then. Because when we are calculating the consumer price index, we are not just taking the price of every good we are buying and then taking the average. But what we are doing, it's not the geometric mean. Take this as example, milk and washing machines. No. So what is the difference if you think about your consumption expenditure? What is then the difference between milk and washing machines? I already said it. Yeah, yeah. And so how do you get then, so to speak, the importance of both goods for your general expenditure, let's say for about 1 month or in general 1 year? How did you get this together? Because obviously, just taking 500 euros plus €1.15 for liter milk, then the price of a liter milk doesn't matter. But of course, milk matters for our consumption expenditure. What are you then doing? And this hopefully you have also done in your introductory courses, because I cannot do everything within 2 weeks to redo it. Well, in my macro course, then I said, well, let's say we are buying every 5 years a washing machine, and within 1 year, maybe we are buying 100 liter milk. And then the total consumption expenditure over 1 year for milk would be 115 euros, or for a washing machine on average per year would be 100. And then you have a weighting between these two goods. Yeah. And this you are doing for every single good, which is in this general basket of our representative household. So we have to have an idea of these different weights. This is what I mean. Yeah. And because of this, then, yeah, if we also would then calculate the change in these yeah, indices which we have calculated here, of course, then we obtain different numbers. So the growth rate of these two numbers, they differ a lot, 2% and a little bit more than 6%. Oops. So this would be then 18 period 3 over 18 minus 1 and 223 over 210 minus 1. Yeah, for this, we then have to admit that in this case, we are looking only at the change of price. But we see also, okay, the quantities we are consuming are changing. So here the quantity is increasing. Here, due to an increase of price, the quantity is decreasing. And this then means that over time, so to speak, the importance of these goods within our total consumption is changing. And here, if we calculate the change in price level just by the change of the average of all prices, then we just ignore that quantities, that the importance is changing. So in this case, we look only at the change of prices and qualitatively we ignore the importance in quotation marks of the good in the consumption basket. Well, and in the other case, we look simultaneously in both, in price changes and in quantity changes. But this is then also hard to, to just use for the change of price level. This is, of course, the change in the consumption level. In this case, we um, use the simultaneous change of quantities and prices, which is also hard to interpret as a change of price level. And so in the end, then we have to ask ourselves, well, what would be the next step in order to come in order to come to a reasonable way, so that we have somehow the importance, but we also do not have just a measure of total consumption, because then both is simultaneously changing. So what is the price of the basket? This we have already done at the former slide. And then we can ask, well, let's fix some of our numbers and change only one of our numbers. So fixing, in this case, what is the price of the basket we are consuming in 2015 using the prices of 2016. Remember also the macro course, there we have talked when we have talked about the Fisher equation. You remember the dependence between interest rates and prices. And there we said, well, we're just investing today 10,000 euros for an interest rate of 5%. And then we have 10,000 euros 500 in the next year. And then we ask ourselves, well, how much is the value of tomorrow having 10,500 euros today? Because we have to make today the decision. And that this is a reasonable question, we have argued that during this year also prices are changing. And then we said, well, we have to calculate the so-called present value of 10,000 euros 500 in the future, given the price development over the last year. So we have divided then this number by 1 plus the inflation rate. Because of course, if we are investing for 5% nominal interest rate, and during this time, prices have increased by, let's say, 8%, then although we have more money, 10,500 is more than 10,000, we can buy less in the future. And in order to calculate something like, well, how is the price level changing, then we can say, well, let's take the quantities of, in this case, 2015 and multiply these quantities of the year 2015 with the price level of 2016, because then we, so to speak, know what the basket in history last year is worth in the future. And if we then compare this with the expenditure in the last year, so here, price level 2015 and quantities in 2015, then we can, somehow reasonably argue that this is a measure of the price change, because then we have fixed the quantities. This means we have, so to speak, the relative importance of the goods fixed, and only the prices have changed. Yeah, and this let's maybe copy the table that we can see this. Oops. Oh, where are we? This we have already done. This I need. So for this number, we multiply the quantity of 4 with prices of the next year. And this number, let's take red, comes just as we have already calculated with the expenditure in 2015. And this is then somehow a measure, an increase of these 28.6% that we could say, well, if we would still consume the same level of quantities, our expenditure in euros would increase by almost 30%. And so in this case, we can then talk of a reasonable measure how only, or how the price level, not the prices, but the price level has changed, because then we have still a measure within the calculation of the importance of our goods. Okay? But of course, we can reverse this argument. Why not taking the quantities of 2016 and value these quantities with the prices of the former year. Sorry, I'm a little bit too fast, I think. Yeah. Or since I have already said this, we just a step to the next slides. We can reverse this argument. So what is then the cost of the basket in the year, oops, 2016? And in the other way, take the old prices. And let's also copy the table again. So this would then mean we take the price of 2015, but taking the future quantity. So this is calculated like this. Then we obtain this 227. And now we are not comparing this with the consumption expenditure in 2015, but we compare this, of course, with the consumption expenditure in 2016. So this would be then that. Well, and I just took the numbers like this. Both measures are reasonable ways how to calculate a change in price level, but we see here a large discrepancy. Because now we would just argue, well, we are comparing today's consumption expenditure with today's quantities with the hypothetical level of our consumption expenditure 1 year before with the prices of 1 year before. And in this case, it would only increase by 1.8%. But again, we cannot say the first is right or the second is right. These are both reasonable ways to calculate a change in price level. Because also, again, we have included the importance of our goods in our consumptions. And if you remember, just go into the slides of the macro cost. There we also said, well, of course, we know that the quantities which we are buying over time on average of these this representative household is of course changing over time. Think, for example, this is of course also a telephone, but it can do much more today. If we go back in time 30 years and you calculate what is your relative expenditure for a telephone is much less compared to this what you are what is your expenditure for your mobile phone contract, for your home telephone connection. Maybe you have also something else. If you add this together, then of course, yeah, our consumption level for goods is changing over time. And because of this, of course, calculating an inflation rate means also that we are over time are changing these weights. And in general, roughly every 5 years, we are changing these number of these weights. But in general, and let's go back, it is the case that in general we measure the change, although we have here two reasonable ways, and in a minute I will show you a third reasonable way how how to measure price levels. In general, we are calculating the the price level change and inflation rate due to, oops, where's my mouse? There. Due to this concept that we take the level of the quantities of consumption in the past for sometimes as fixed, and then are measuring these quantities due to the price level change, or not the price level change, due to the individual price change of these goods. So we are fixing, right now it is the year 2020, that we there fix the quantities, and then we take this as the quantities of the representative household, and then just look how are the single goods are changing in prices, and multiplying these quantities with the new prices over time. This is then our, in general, inflation rate. And this kind of price level change measurement, this is due to a French guy who is called Lasper. And therefore, this is called a Lasper index. And your fellow students, I recommend, and here I gave you also, this is the link for the price measurement of the harmonized consumer price index from Eurostat. There you find a description and almost similar description of the consumer price index from the statistical office in Germany. Then you can click here. Here you find a link to the weights. So if you're the next day, just look at these pages. So it would be nice if you then, in addition to the specific tasks and exercises which I gave you, that you also talk a little bit in general. Well, how is inflation measured? Because it is a little bit more complicated than I have showed it to you here. And yeah, here you see this is then the weights of the single goods. So these weights are represented then just by these quantities which we have here. So if we take these summation signs, then you see here, okay, we take some period as the base year, 2020, right now, and then only, yeah, going up into to time in these singular prices here. So what you then can interpret is, oops, let's take another. Here we have period 0 here, you have period 0 here. So this is a fixed number, and then this number over this number would then represent your weight, because only this t here is changing. Oh, sorry, this what? Times the, here I heard, times the price level in times 0. And then in general, you can interpret this as the weighted arithmetic mean of the price level. And this, of course, then means that the sum of GI0 adds up to 1 to 100%. And usually we are using this method in order to calculate inflation. Well, this has, of course, also practical reasons, because otherwise, if we would take the future or always the actual quantities, then we have always to revert this back into history. And doing it in this way, we just can say, well, let's fix 2020, and then the next 2, 3, 4 years, we use this as fixed. So we know what we have done in history, because otherwise we would have a practical problem. It's also a reasonable price level measurement, but we would have a practical problem that, of course, we do not know how much we are in quantity consuming in the future. Okay, so about this, maybe you can talk a little bit how it is then definitely done. And the other way around, so taking today's quantities valued with the prices in history in the former years. This is due to a guy called Pasha, also in the beginning of the 20th century. And if we then look in more detail in this formula, so here we have always the t's. So these are the today's values, and then we are valuing this today's quantities with a price level in history. This we can rewrite in this way. You see here, if we are writing this like this goes down here. So 1 divided by 1 divided. So it comes back to the top, okay? So that this is down here, this is 1 over x is just x. And here we have the same numbers. So this is just by multiplying with 1. This I said, this we do quite often, multiplying by 1, a complicated 1, or adding a complicated 0. You have done this last week. Here we are multiplying with a complicated, so to speak, 1. So this is just 1. So this cancels. here we have the summation sign. So this is just then summation over P0 times xt, and this we just find here. So now maybe also if you go later on tomorrow or so a bit slower through this formula, then you see that this is equal. Well, why I'm doing this? Well, remember the harmonic mean. This was 1 over n to the power of minus 1 times x1 to the power of minus 1, x2 to the power of minus 1, and so on, xn to the power of minus 1, and then again, power of minus 1. So almost the same as the arithmetic mean, but just adding at every single variable the inverse. And here we see that writing it like this, that this then means that the partial index is just a weighted harmonic mean of our price developments. And this I haven't told you in the macro course, but this you can show them. If you remember, we have introduced how we are calculating real GDP. So we wanted somehow to get rid of the price change in order to calculate real GDP. And there we said, well, let's value today's quantity with the former price level. And then we have defined the overall price index as nominal GDP divided by the index of real GDP. And if you take all this together, then you can show that this price level measurement for gross domestic product represents just a price level measurement as we do it here, so that it is just that the GDP deflator is just a partial index. So GDP deflator is formally just a partial index. And maybe this we can also say, if you remember the expenditure approach of GDP, then we said, well, GDP is private consumption plus investment plus government expenditure, government consumption plus investment plus exports minus imports. And then, of course, we have also, as we have here, the GDP deflator. We have, of course, also for this component, the private consumption deflator. Well, and this private consumption deflator is, of course, also a measurement for the price level change of the component of private consumption. But here we are using the concept of the Paasche index, and in general, when we are talking about inflation, and there, remember, inflation, we take a representative household. What is this household consuming? For this, in general, we take the Laspère concept. So we are in the end we are calculating both. If you go to the national account system and calculating there, and then you are looking up this private consumption deflator, then this is calculated due to the Paasche concept. And in general, when we are talking about inflation, then this is calculated due to the Laspère concept. Okay, and then, yeah, we can ask ourselves, what are the arguments for the one concept or for the other concept? And of course, in general, as in almost every lecture, you hear that the quantities we are buying or selling is depending on prices. So these quantities are always changing and reacting due to due to price changes. So then, especially in microeconomics, you have talked about complementary goods and substitutive goods. So in general, well, yeah, how large this level of substitution is, you have then also a dependence on the change of the quantities on other goods. So these quantities are not only depending on the price itself, it is also depending on the price changes of other goods. And therefore, we have to ask, well, how sensitive is our concept due to these changes of prices, so that we know that over time our quantities are changing? Because in the one concept, we take the today's quantities as fixed, Paasche, and in the Laspère concept, we take the quantity in history as fixed. And also what we see over time is, of course, we have new goods. Again, in the first real handy was, I think, the iPhone in 2007 or 2008. So when we really want to talk about some device which can more than just to call somebody else. And this then means, well, okay, if we fix the quantities in history and we are inventing new goods, then we do not find these goods. So this would be then maybe an argument for the Paasche index. And also what we find is that, well, we have still the same goods, but they have changed in quality. And again, I would say that the mobile phone is a good example for this, how fast this development is. But right now here at our university, we are changing our web pages because we want them to be better usable for the mobile phones. Because when we started with our web pages, then everybody said, well, we have a screen which is quite large, and yeah, therefore, in general, yeah, we could say, and this will be then one task, which maybe you can show us next week, is that in general, we would say, or in general, we would see that the Paasche index is lower, or the inflation due, or the price level change due to the Paasche index is lower compared to the Lasper index. And the reason for this is that in general, we would say that quantities will be negatively correlated to the price development. So the higher the price, the less we buy. And yeah, this maybe you are showing us next week. That this we can also see by the definition that this is the case. And having this result, then in general, we could say, well, the Lasper index is, or measuring price level development with this Lasper index is, so to speak, somehow a little bit more conservative. Or no, the other way, sorry, the other way around. That this, yeah, somehow overestimates a little bit. But this statement overestimates just only means that it is compared to the Paasche index larger. And okay, well, what can we do if we know this result, or what could be an idea if we would say one index is overestimating and the other one is underestimating? What could be the idea to create a new index? We take the mean. Yes, of course. And this, very surprisingly, is done. And this is the so-called Fisher index. But here again, remember in the end, with these indices, we want to measure in general inflation, the change of price levels. And this is a growth rate in general. And therefore, we do not take the arithmetic mean of these, which at the first step would be also a reasonable choice. But since we want to measure growth rates in general, because of this, there was a guy, this is the same guy as Mr. Fisher from the Fisher equation with the interest rates and price and inflation, that we then just define the Fisher index as the harmonic mean, as the geometric mean of our former two price indices. Yeah, and we have already calculated this before, and in this case, we would end up then with an Fisher price. This should be then not a P, but an F for Fisher. Sorry. a Fisher price, and this also. Of 1.236, and I haven't. No, I have only 2 years, so I can only calculate this. In order to obtain then a growth rate or an inflation rate for the Fisher index, we would need a third year because we need for the indices, for the Paasche index and for the Laspère index, we need 2 years, and now we need both 2 years. So in the end, to calculate a growth rate, we would need a third year. I think for this, I gave you also some task that you then can calculate the price level change. Yeah, and to my knowledge, it is the case in Europe for the GDP deflator. We use the concept of Paasche to calculate this, and to my knowledge, in the United States, they use this Fisher concept to calculate the GDP deflator. Well, in the end, it's maybe the second or third digit, but in the end, it's a different measurement. And this one has always to keep in mind when we are comparing numbers internationally, that maybe the calculations are differing. And this statement I made here, that of course the numbers can differ because our economies are growing differently, but it can also be just the case because we are calculating the growth in other ways. Okay, and the last one is something which you have already done, but in order to be complete, I want to do it with you another time. Is of course quite often we do it via these chain indices, and this is then the real GDP, and this we had done in macroeconomics. So the GDP deflator, sorry, it's the German one. I didn't change it into English. Oops. That we have defined real GDP taking today's quantities times the prices of the former year, and then calculating the GDP deflator as the ratio between nominal GDP versus real GDP. And the 100 I explained is just a numeraire because we want to have this index in the neighborhood of 100. So, and the little difference to the other measurements we have done is here that we have here the real index of today is chained to the former year. And calculating inflation, as I said, is we always taking one specific base year, and then we are fixing the quantities or the weights, and then for the next, if nothing really bad happens, then for the next 2, 3, 4, or in general 5 years, we do not change these weights. And in order to calculate this real GDP, this is directly dependent on the former year. So, and yeah, the nice property of this is that this means that the growth rates over time do not change because we are changing every year. And if you are definitely fixing 1 year and then you are changing later on in 5 years your weights, then in general you would have to also to change everything in history. Well, looking at the inflation rates, we do not do this. So this was only the case in 2023. There, it was announced in January that the inflation rate in Germany was 7.9%, and this was the highest inflation rate since World War II. So of course, this went through the media. It was, I think, in the first oil crisis in 1973. There we had once, I think, roughly 7.2%. So it was the highest one, and then just 4 weeks later, this was decreased to 6.9. And the reason was, I think I had it here on the slide, that this weight changed, or they recalibrated it. They recalculated the weights from 2022 to 2023 just in February. So this weight here, and in general, you see here gas and other fuels. This is, of course, oil. And this weight was decreased to 25.9%. And the former weight of this was roughly, if I remember it right, before 2023. This weight was roughly 32%. So due to the war in the Ukraine and the very high oil prices, the first announcement of inflation rate was 7.9%, and then they changed just 3 weeks later the weights, and especially the category where you find oil specifically directly, and therefore the inflation rate really decreased by a large amount of 1 percentage point from 7.9% to 6.9%. So, and this, of course, in statistics, you always have to know what you are measuring and how you are doing this in order to interpret your numbers. Okay, 5 minutes. We have already done this, but I think in this 5 minutes we will make this. That again, let's calculate nominal, real, and the price development due to the GDP deflator. So in macro, I used just an example with TUI goods, if you remember this. And here now, in general, we take the expenditure approach. So we have government consumption, private consumption, government consumption, investment, exports, and imports. And I gave you always the prices and the quantities. So how would we then calculate nominal GDP? I think we make this in 5 minutes, or you should remember this from last semester or last year. I do not know when you have taken macroeconomics. So total GDP is just nominal. Yep. Sum it up, and we have to be careful. We have in the end exports and imports. And what do we have to do then? With the imports, we are not adding the imports, but yep, subtracting, yeah, of course. We have to buy the oil, unfortunately. So, price times quantity plus price times quantity plus price times quantity plus exports times quantity and minus imports. Price times quantity. So we have done this. We can copy this formula down here. And now real GDP, today's quantities with the former price level. So in 2018, we cannot calculate this, but for 2019, this would be then 1.2 times the former quantity plus 1.05 times the former quantity 3 plus 0.95 times the former quantity 3, and then exports also adding minus imports. So, well, in general, we can just choose because we are only interested in the end into the change of the GDP deflator. We can choose just 1 year as a base year. So let's choose 2018 as the base year, and then nominal GDP divided by really GDP times 100 is our next deflator. So equals nominal over real times 100, and then uh, growth rate of GDP Deflator would be then, of course, first 7% minus 1. Then we had it have a decrease, and the last one an increase. Percent is here, and let's take 2 digits. And that's it. So I think this one I need R. I think I can directly copy this inside here. Nee, geht nicht. You see, it's not that easy. Wie machen wir das am besten? Maybe somehow like this. Almost. Here we are. Thank you very much.